Yeah, so it was a good weekend. Uh, did you not hear what my weekend was filled with?
Was the plumbing that important? No.
Yes. Okay. So translations. Okay. So if you have a normal y equals x squared, and you're given y equals -2 times x minus 3 20 squared plus 5, Michael, what happens to this graph? Right? 3. I'm good with that. Up 5. Good with that. Oh, you are so good. Reflects over the x axis. And then um, we say it stretches by 2 vertically. Okay? So the negative is the thing that reflects it over the axis. The 2 is the thing that stretches it by 2 vertically. Okay? Now, stretching by 2 vertically will do what to the graph? Will make it a little skinnier a little bit. Okay? It's going to make it a little skinnier because of the stretching up of it. Okay? And then right 3 and then up 5. Is everybody good with the whole translations? We've done this before. We have just a couple more problems over that. Okay? Anybody have any problems with that? Okay. Now, end behavior. If it's even, it'll start and end in same place. So if we have x squared, it'll go like that. X to the 4th, it'll go like that. X to the 6th, it'll go like that. Okay? If it's negative x squared, what happens? Both are down. Negative x to the 4th, negative x to the 6th. Okay? You get the gist of what's going on there, right? Okay? There's just that many more humps to it. If it's odd, okay? If it's odd, it'll start and end in opposite places. And what am I talking about even and odd? The what? The degree of the polynomial. How do you find the degree of the polynomial? It's the highest degree term that appears. Okay, the highest degree term that appears. So let's say we have x cubed. It'll go like this. It'll, as we go towards negative infinity, it's negative. As we go towards positive infinity, it's positive. If we have x to the 5th, okay, boom, 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 boom. There we go. Again, same type of thing. If we have negative x to the 3rd, it'll start this way and go that way, negative x to the 5th. It'll go like that. Okay? So I say, look at when it's a negative in front, look at where it's going to end. Okay? So if it's negative, it's always going to end going down. If it's negative, it's always going to end going down. If it's odd, they're going to go opposite. If it's even, they're going to go in the same place. Okay? We good with that? Okay, that's end behavior. For this is back to what Michael was doing with us. The graph is translated how many units to the what direction? 5 to the left. And it stretches by a factor of 2 vertically. Okay, and then they'll ask for the y-intercept. What's the easiest way to find the y-intercept besides throwing it into your graphing calculator? You put 0 in for what? The x or the y? The x. To find the y-intercept, put 0 in for x. If you put 0 in for x, you get 5 cubed. 5 cubed is 125 times 2 is 250. Okay? Capiche? All right. I'll skip over that. I think you can figure that stuff out. So what you're going to see today is you're going to be matching graphs like this. Okay. So this one is easy enough because when you have a 5 versus a 3, what's the difference? The number of humps in between. Okay. This has an extra hump in it, and this one has an extra hump in it because, it's not a true hump, but it's got a little waver in it. And when it's a little waver, that's like a hump. Okay? So then you just look at the first term coefficient. If it's x to the fifth and it's negative, it's going to end up or down? Down. Okay? So this one goes here. The first one has an extra hump. It's going to end going up because it's positive. This one is positive, so that goes to that one. And this one is negative, so it goes to that one. Okay? So it just depends on the power and the number of humps you have. Okay? And I want to see what, there it is. Leading coefficient, yeah. So it's talking about leading coefficients. You'll have drop downs on yours, and it'll make sense when you get to there. All right. How do we find the y-intercept? One more time. Stick 0 in for x and solve. Okay. All right. So this one, okay. Which one is it most likely to be out of these? Well, what type of a graph is it? Is it a second term, or is it a quadratic, a cubic, a quartic, a quintic, what? It's cubic. And it's a negative first term coefficient. So we have to find one that has a negative. So this one, what's the power on that one? 4, because there's 1 here, there's 2 here, and there's 1 here, so it's a 4th degree polynomial, so that one's out. What about this one? 4th, so that one's out. What about this one? 3, this is 3rd, and it's a negative, positive, positive. A negative times a positive times a positive. That looks like that works. And this one's a 4th, so that's why that one doesn't work. Why doesn't this bottom one work? Right, the x is negative in the last one, so a negative times a negative is a positive. So that's why that doesn't work, because it has to be a negative first term coefficient, a negative for the x's. Okay? All right, this one should be a what? How many x's do you see? 3, so it's a cubic. Okay, so it's a cubic. Now, its x-intercepts are 1, -3, and -2. How did I find those so quickly? you set each of these equal to what? 0. And then you find the x-intercepts. So my x-intercept, I have a 1. So I'm going to cross at 1. That's neither of these. It's some other graph, some other place, okay? So I'm going to cross at a 1, a -3, and a -2. So it's not this one, and it's not this one. So it must be one of the other graphs, okay? So what happens is it comes up, crosses at -3, crosses at -2, goes down and crosses at 1 again. So it looks like that, okay? So what's the end behavior? As we go towards infinity, what happens? It goes towards, as the x value goes towards infinity, as we're going to the right, what happens to the graph? Up to infinity. As we go towards negative infinity, what happens to the graph? Down to negative infinity. So as we go towards infinity, it goes to infinity. As we go down towards negative infinity, it's negative infinity. Okay? And behavior of this one. What letter of the alphabet is this going to make? A W or an M? A W. Why a W? Because it's a positive first term coefficient. Okay? And a fourth degree will have an extra hump in it. So as you go towards infinity, where does it go? Infinity. As you go towards negative infinity, where does it go? Up to infinity. So as we go, and then I don't know how they want this one to be answered, but as we go towards infinity, it's infinity. As we go towards negative infinity, it's infinity, because the degree of the polynomial is 4. Okay, fourth degree polynomial. This one, what's the degree of this polynomial? 3. What's first term coefficient? Positive or negative? Negative. You gotta go the highest term, the sign in front of the highest term. So it's going to look like this. Okay, it's going to look like that. So as we go towards infinity, it's negative infinity. As we go for negative infinity, it's infinity. And the degree of the polynomial is 3. I think that's how they want us to answer number 8. Let's look. The degree is 3, and the leading coefficient is -1. I don't see where they even asked about the leading coefficient because it probably went off the paper. Okay, so I will assign those out to you. You've got 8 problems to work on translations and end behavior, and then we'll continue on in the second half class.